Okay, so in this video we're going to look at how to do analytic evaluation of limits. So in the last section we did things pretty fast and loose. We plugged in a lot of numbers, we just kind of drew a bunch of graphs and got limits that were correct, but why they were correct was not perhaps very clear. So we'll look at now some of the starting points for how to do this in a very precise and analytic method. So we'll call this analytic limits. Okay, so for many functions that you run into, evaluating limits is very easy. So for example, one set of things where this is easy are polynomials. Taking limits of polynomials is extremely easy. So let's just do a couple of quick examples. Let's say that I wanted to evaluate x goes to 3, limit as x approaches 3 of the function x squared. Okay, if we drew a graph of this thing, or we started plugging in numbers, we'd expect that it's probably going to be about 9, and in fact it is. Okay, so for polynomials, the limit as x approaches a of f of x does in fact equal f of a. Okay, now I have to stress this, right? This is just for polynomials. It's not true for general functions. So if you're dealing with a polynomial, you can just plug in this number to this function. So in this case, 3 plugged into x squared gets us 9. That's exactly going to be the value of the limit. Okay. So it's kind of nice that with simple functions like polynomials, you can just kind of cheat and do it. Now, this isn't the only set of functions for which you can do this. So you can also do it for radicals or functions like that. Okay, so let's say that you have a composition of functions. And the outer function is somehow nice. So let's take sort of as an example here, something like x plus 5 square rooted. Okay, and let's say that we were interested in the limit as x goes to 11 of this function. Okay, so one of the nice things about square roots, or any kind of radical for that matter, is that you can sort of slip the limit inside. So this is actually the same of taking the limit on the inside and then square rooting the answer. That's kind of special that this will work, but it'll make things pretty easy to compute because this thing inside is a polynomial. It just happens to be a linear one in this case. And so as x goes to 11, x plus 5 goes to, well, what do you think? 11 plus 5 is 16. And then we take the square root of 16 and we get 4. Okay. All right, so again, the lesson here is square root functions are usually pretty nice, provided that you can actually plug in the 11. So if we had done something like negative 11 here, then of course this would make sense because you can't take the square root of a negative. Right, so, but we didn't have that. Just use your head. Nice functions like this behave nicely. Okay, and then the last example would be something like division. So let's say that we have, so we'll call this a rational functions or division. So let's say that we were considering the limit as x goes to 3 of 1 over x. Well, the function 1 over x is usually pretty nice, except of course when x equals 0. However, if the x's are approaching 3, we're nowhere near 0. We don't have to worry about the division by 0 in this case because we're nowhere close to it. And so we should expect that this is just 1/3. Okay? Essentially just the value of this thing plugged in. So for division, it's okay to plug in provided you're away from asymptotes. So maybe we could say this a little differently, that you're well within, let's erase that you're well within the domain. Now that's not really a very very good mathematical term, but I hope you get kind of the idea. So my point there is that not only is 3 in the domain of this function, but it's nowhere near the problem points for this function, namely 0. We might be in a little bit more trouble if we try to do something like 3.0001 or something like that. Okay, so just to kind of recap, nice functions behave nicely. And we'll kind of talk a little bit more about sort of a few other kinds of nice functions, or what happens if you've got, say, combinations of 2 nice functions. What do you do there? And then we'll look at, okay, these functions are all pretty straightforward. They're all pretty simple. But what about if we had functions which were not so nice? Or we were trying to deal with a division case where we were we were very close to 0, or something that's not in the domain. So what do we do in those cases? Okay, so the problems will be pretty straightforward. They'll be kind of like these, and that'll kind of get you used to the what this sort of notation, this limit notation, is trying to get at, and then we'll take care of the sort of really technical and evil examples in class.